Electric charge. Electric charge is the property associated with mass due to which it produces and experiences electric and magnetic effects. It is a scalar quantity. SI unit of charge is coulomb. There are two types of charges, one positive, another one negative. Proton has positive charge plus E, electron has negative charge minus E. The value of E is 1.6 into 10 to the power minus 19 coulomb. Neutral body means the body having equal opposite charges. To electrify the neutral body, we need to add or remove one kind of charge. You know that electrons are transferred from one body to another body. That is why we can say that loss of electrons means positively charged body and gain of electron means negatively charged body. A body can be charged by friction, induction and conduction. Friction. When two bodies are rubbed together, electrons are transferred from one body to other body. As a result, one body becomes positively charged while other negatively charged. When we rub a glass rod with silk cloth, then some of the electrons from the glass rod are transferred to the silk cloth. Thus, the glass rod gets positively charged and silk cloth gets negatively charged. Induction. Let us consider an uncharged sphere. If we bring a negatively charged rod close to the sphere, the electrons in the sphere move away due to the repulsion and near end of the sphere becomes positively charged. Now, if the far end of the sphere is connected to the ground by a conducting wire, electrons flow to the ground. When the sphere is disconnected from the ground, the positive charge remains held due to the attraction. Now, if we remove this negatively charged rod, then the positive charge is distributed uniformly over the sphere. In this experiment, the metal sphere gets charged by the process of induction and the rod does not lose any of its charge. Thus, induction is a process by which a charged body can be used to create other charged bodies without touching them or losing of its own charge. Conduction. If a charged body is put in contact with an uncharged body, the uncharged body becomes charged due to the transfer of electron from one body to other. For example, consider two identical spheres A and B. Let A has charge Q and B is uncharged. Now, if these two spheres are brought in contact and then they are separated, the charge on both spheres are same Q by 2, Q by 2. It is the average charge. This has charge Q, here B has charge 0, so total charge on both will be Q by 2. Now, if A has charge Q, let B has charge 3Q. If these two spheres are brought in contact and separated, then the charge on them will be Q plus 3Q by 2. So it is 4Q by 2 means 2Q, 2Q. Basic properties of electric charges. Number 1. Additivity of charges. Total charge on a body is the algebraic sum of all the charges located anywhere on the body. If the system has charges Q1, Q2, minus Q3, Q4, then the total charge is given by Q1 plus Q2 minus Q3 plus Q4. While adding the charges, their sign must be taken into consideration. Charge is conserved. Total charge of the isolated system is always conserved. Quantization of charge. Free charges are integral multiple of a basic unit of charge denoted by E. Q is equal to plus or minus NE, where N is an integer, positive or negative. The basic unit of charge is the charge that an electron or proton carries, means E. Electric charge is always an integral multiple of E, termed as quantization of charge. A body can possess plus 10E, minus 9E, plus 5E charges, but it cannot possess 2.5E, minus 0.5E, 1.5E charges. Charge is transferable. Charge produces electric field and magnetic field. A charged particle at rest produces only electric field, and a charged particle in motion produces both the electric and magnetic fields. When charge is kept on any conductor, it resides on the outer surface of the conductor because like charges repel and try to get as far away as possible from one another and stay at the farthest distance from each other, which is the outer surface of the conductor. This is why soap bubble expands on charging. True test of electrification is repulsion and not attraction, as attraction may also take place between a charged and uncharged body and also between two similarly charged bodies.